So 6.F.1, I like to think of this section as the why do we care about factoring section. Ultimately, it's so that we can solve more equations. Up to this point, the only equations we've worked with have been linear equations. So this is a very simple one, but the idea of solving a linear equation is simply to get that x by itself. So you can start by getting the x term by itself, and then getting the x by itself. And then you'll have your solution, x equals a number. This approach does not work, however, if we encounter an equation where our variable has any kind of exponent, any kind of power on it. The getting x by itself doesn't work. There's no moving terms and dividing to get x on its own. So this is where factoring will come in, but along with a very important and fairly simple property called the zero product property. The idea here, it says if a, b equals 0, meaning if a times b, if two things multiply together, two or more actually, if things are multiplied together and your answer is 0 from that, then you know for a fact that one of those things has to be 0, right? A times b is 0, then one or the other is 0. Meaning 0 times something is 0, or something times 0 is 0. This wouldn't happen if they weren't, if neither of them were 0. Also important, this only works for 0, right? If I said something times something is 8, it's not the case that one of those things has to be an 8, right? It could be 2 times 4. But for 0, this specifically will always apply. And so the idea here is a product form. Well, that's exactly what we get when we factor, is a product. That's why factoring will help us solve more equations here. Now, the process is right here, but instead of jumping into that, I kind of want to work backwards with that process. I want to start with just something of this form, an equation where it's something times something equals 0. So, using the property, bring that back down from above, the zero product property, I've got something times something is 0, so that property tells me that either the x plus 2 or the x minus 3 would have to be a 0 for that to happen. That's the only way. All right, a times b is 0, then one of those things is 0. And as soon as I write that, you'll notice these are two very simple linear equations. It takes a whole single step to solve. Subtract the 2 or add the 3. But notice we get multiple answers. We're going to get two different solutions here, and it's actually the case that they're both correct. Think of checking them, -2. If you plugged in -2 here and here, -2 plus 2 would be a 0, which means I actually don't even care what this is. -2 minus 3 would be a -5, but 0 times -5 would be 0, so that works. And then same with the 3. Plug 3 in here. 3 plus 2 is a 5, but 3 minus 3 is a 0, and 5 times 0 is 0. So they both work. They are both solutions to that equation. Okay? This is something else new to us. We've not seen an equation with multiple solutions up to this point. So that process that we just did there is actually the third step mentioned up here, setting each factor equal to 0. Once this thing is in factored form, and notice that looks like something we would have seen from factorings we saw earlier in the chapter. In factored form means product form, something times something, and we can break those apart into very simple linear equations. So, going on to number 2. We have this 0 on the right, but we've got a polynomial here. This is not in factored form. In fact, that looks just like something we could factor. So we'll go ahead and factor it, starting with our always first step GCF, but that doesn't help us. Now it's an x squared x no x with a 1 in front, so this is an easy case x squared x no x, easy case number game. So let's find things that multiply to a -4. Not too many things do that, 1 and 4 and 2 and 2, but also add to a +3. So to multiply to a -4, they've got to be opposite signs, and we would want a -1 and a +4 to add to a +3. So remember, with the easy case number game, we are now just breaking this thing down to two binomials that each start with x, and the number game fills in those blanks. Now, don't forget to bring down the equals 0, right? That's what we just did. We factored the left side. It's equal to 0. But now we're back to here. Now we can say if this times this is 0, then either x minus 1 equals 0 or x plus 4 equals 0. And so again, one step gets me that 1, one step gets me that -4, and there are our two solutions. And so this shows us the second and third step, where we had to factor first, and then set each factor equal to 0. So before we leave this page, just to point out, I mentioned that the zero product property only works when it's a product equal to 0, That's why our first step that we're going to need to do, and we'll see on the next page, is setting equal to 0. Meaning we want to make sure that before we factor, before we work with something like this and factor it, we have to see equals 0. We need all the terms on one side of the equation, something we normally never did with linear equations. But for this approach, we want to see this 0 on the right side. So we're going to want all the terms on the other side, whether it's the left or right, doesn't matter. And then I'll just mention down here again, don't forget, you can always check any of these answers by taking them and plugging them back into the problem. Plug in 1 everywhere, plug in -4 everywhere, make sure they do work. You can always check your solutions to any equation. All right, let's look at this next one. So like I said, we see equals, but not a 0. As soon as you see this extra power, this is not a linear equation, we're going to solve it by factoring. So the first thing we will do is move that 6 over. X squared minus 5x plus 6, because we need to see that equals 0. All right, now that we see the equals 0, now we can work on factoring. To factor this, notice GCF is 1, doesn't help us, and it's an x squared x, no x, easy case. So, number game for a 6 is 1 and 6 and 2 and 3. Now, we want them to multiply to a positive 6, but add to a negative 5. So we're looking at both negatives, right? Because this is this positive 6, so they gotta be same sign. So we would need a -2 and a -3 to multiply to a positive 6, but add to a -5. So we can fill in our binomials, and I'll make sure I don't forget the equal 0 there. Start off with x's, fill in those blanks with the number game, -2, -3. And then I'll kind of squeeze it in here. We can have x minus 2 equals 0 and x minus 3 equals 0. We can then break those apart and solve them, right? Add 2 to both sides or add 3 to both sides. And we're going to get our 2 separate answers, 2 and 3. So the next one here, again, if you don't see equals 0, that's the first step. Get it so it says equals 0. So I'll move the 7x that way. It's not that I want to just always default to moving to the left, but you want your highest powered term to be positive for factoring purposes. So since x squared is over here, that's why I'm moving the 7x, like that. But now it's equal to 0. All right, so now with that being said, we want to factor. And factoring here, first step GCF actually does something for us, right? We see an x in common. Let's factor out that x first. Factoring out an x leaves me with an x for that first term and a -7 for the next term. And notice that with that factoring, we're done factoring. There's nothing else to factor, and in fact, these are both linear. Now, to look at them, to break them apart, I know this doesn't look like the other ones, but this is one term, this is another, in terms, or one factor, I should say. And when I write that equation, I write x equals 0, and that's an answer. Now over here, I'll write x minus 7 equals 0, and we'll do what we're used to, adding the 7. But notice, again, this gave me a solution, and then there's my other solution. All right, next one. Again, we don't see equals 0, so we want to get that first. So I'll move the 25 on over. X squared minus 25 equals 0. Now we can factor. First step, GCF. GCF of 1 doesn't help. Now, what do we have here? We have a binomial, 2 terms with a minus sign. This is going to be our AB approach, our difference of squares. X is what you square to get x squared. 5 is what you square to get 25. So we just need to remember our formula. The a squared minus b squared breaks down to a plus b and a minus b. And then from there, factored equals 0. So make our 2 separate equations. X plus 5 equals 0 and x minus 5 equals 0. Subtract 5 there gives me a -5. Adding 5 there gives me a +5. And there's our 2 solutions. All right. Next one here. We do see an equals 0, so that's good. First step taken care of for us. Next step is factor. So first step GCF. Notice we do have a GCF here. GCF is 2. Let's factor out that 2. We need to, because otherwise we could not do anything with this. But factoring out the 2 leaves us with that left over. Notice because of that, now this is an easy case x squared x no x. So now we can break this down using our number game. So -6, things and multiply to -6 or multiply to 6 there. Now to multiply to a -6, but add to a -5, that tells me they got to be opposite signs. That tells me the bigger number's got to be negative. So it looks like negative and positive. And so x plus 1 and x minus 6. Now, notice here we have 3 things multiplied together. This times this times this equals 0. This guy here doesn't involve x at all. We do not need to make this into an equation. We do not need to set that equal 0. In fact, if you did, and I'm not saying you really need to write this, but if I wrote, so maybe 2 could be 0, that doesn't make sense, right? There's no reason to write that. If it doesn't involve x, it's not going to give you a solution. We're looking for answers to x. So this could be 0, or that could be 0. And so then we solve for x for each of those, and we get our 2 solutions, -1 and +6. Now the last one isn't just a tricky form, but once we understand what to do with this tricky form, we're good to go. We've got what looks like a factor, what a product on the left, but not a 0 on the right. So we said we want 0 on one side, but we also want to be able to factor what we're left with whenever we move this term. And if I just subtract 21 over here, this will just look confusing and like nothing we've done before. So what we're going to do is what I'll call the multiply and move step, right? I want to actually multiply this out so I can see the individual terms. If I do that, I'll get x squared minus 4x. But I also want to see 0 over here. So if I move the 21, subtract it over to that side, notice with that one step, now we have something that looks like something we can factor, something we can recognize, right? So that kind of setup there, if you ever see that, a product on one side, but not 0 on the other, we need to move it over, but also multiply it out so that we can then factor everything on that side. So with that equals 0, factoring first step GCF doesn't help, and now it's the number game time. Numbers that multiply to 21 would be 1 and 21 and 3 and 7. To be a -21 and a -4, that tells me opposite sign. That tells me negative's the bigger number. There we go. And so binomials that start with x's with a +3 and a -7. Then you can set those up as their own individual equations. Get -3, get -3 there. Get +7 there. And our 2 solutions.